Okay, everyone. So we talked about in the previous example problems how to factor in two different methods. We talked about if you have two numbers and you are subtracting and you have two perfect squares, one of the factoring techniques we can use is called a difference of two squares. Also, if you have three terms, one of the methods we can use to factor is slide and divide, or general factoring. But sometimes general factoring or slide and divide will fail us. We won't be able to use it. There will not be two numbers that multiply to be a times c and add to be b, no matter how much we want it to. Okay, so sometimes factoring will fail us, but there is something that always works called the quadratic formula. So we're going to go over the quadratic formula, which this should be a review from your previous math sections. But anyways, before we talk about the quadratic formula, if you notice, this nifty formula has a square root in it, so we need to know how to simplify when we have a square root, which again, this should be a review from your previous math classes. Okay, alright, so let's talk about what it means to be a square root. Let's just talk about what that means. Okay, so if I have like the square root of 9, this is just kind of a side example, doesn't have anything to do with these. We know it's 3, but the reason why it's 3 is because square root means I need two numbers that multiply to be this value, and it needs to be the same number that's multiplied to itself. Okay, and this is going to be 3 times 3. Okay, so basically, if I break down 9, okay, it breaks down into 3 and 3. And see how there are two 3's that multiply to be 9? Holy hot dogs. So that means for every pair that we circle, this is called a factor tree, for every pair that we circle, one will hop outside the radical. And since I have nothing left in the factor tree, my answer would simply be a 3. So the square root of 9 is 3. Okay, but we're going to talk about some square roots that don't always work out. So they're not perfect squares, but we can simplify or reduce them down. So the way that I simplify radicals is by a factor tree. Now, there are other ways to simplify radicals, which if you prefer to do that way, that's fine. But the way I like to do it is by a factor tree. So what we do, we start by writing all the numbers that go into 27, and we keep breaking down the numbers into things that go into those numbers until the only thing that goes into them is 1 or itself. Okay, so 27. Some things that go into 27, 9 and 3. Okay, now I can't break down the 3 because only 1 and 3 go into 3. So my 3 is going to come to a hole. But my 9, I could keep going. Two things that go into 9 are 3 and 3. Okay, so when we're simplifying these square roots, we need two numbers that multiply to equal something. So we're looking for pairs of numbers. So when we look for pairs of numbers, you guys, we're gonna look at the ends of what I call the branches. So basically, if something breaks down, like the 9, we do not look at it for a pair. Okay, so the 9 broke down, so I don't care about the 9. And the 27 broke down, so really, I don't care about the 27. The only things I care about are these numbers that are at the ends of my branches. Okay, now over here, we're looking for pairs, and if we spot a pair, we circle it, and for each pair, one number will hop outside the radical. Okay, so let's see here. I'm looking for pairs. Which the analogy I like to use, you guys, we're looking for cute couples, and if you spot one, they get to leave and go on their hot math date, which means they hop outside the radical. If we have any numbers that are left over, they stay inside for the night because they're lonely and they're single and they're sad. So they're going to stay inside of the radical. So any numbers that are left out of these three numbers will stay inside the radical, and for every pair we circle, only one will hop outside the radical. So let's see, out of these 3's, do we spot a pair of 3's? Holy hot dog, I do. Which I could circle these 3's, I could circle these two 3's, or I could circle these two 3's. It does not matter where they are located. Okay, I'm just going to circle these two 3's. Okay, and I don't see any other pairs. I have one lonely 3 left over and no other pairs. Okay, so my final answer for the ones that I circle, okay, I found my cute couple, so they get to leave the house for the night, or they leave the square root. Okay, so I have my square root. This pair of 3's leaves the square root, but for every pair, only one comes out. So I'll have one 3 come outside the radical, and then my lonely little right here will stay inside the radical. And that's it, you guys. We have simplified that radical. Awesome. All right, now some comments to make. If you ever have more than one thing circled, that means more than one thing will hop outside the radical. And if you have more than one thing hop outside the radical, we will multiply them together. Same thing, if you have more than one single lonely number left over that does not have a pair, they will stay inside the radical and you multiply them all together. So basically, rule of thumb, if you have more than one thing outside or inside the radical, you multiply them together. Okay. Alright guys, now moving on to B, which you're probably like, holy hot dog, Miss Long, what is this negative doing in the problem? Okay, so we also need to discuss something called an imaginary number, which is I. You've probably learned about I in your previous math class, but let's refresh what that is. I is equal to the square root of -1. Okay, what this means, you guys, it is not possible for two numbers to multiply to themselves and you get a negative if they are the same number. For example, if I have like a +3 times a +3, that's equal to a +9. And if I have a -3 times a -3, that's still +9. So no matter what, if we square root a number, okay, it's not going to be negative. We can't do it. I can't get a negative when I multiply a number to itself. So this is imaginary. So basically, you guys, if you ever see a negative, what's going to happen is this is an imaginary number. So an I is going to appear outside the radical. Okay? So looking here, I have spotted a negative. Holy hot dog. Okay, which I can't do my factor tree till this number is positive. So the way that we get rid of this negative is to have an I hop outside of the radical. Okay, so I'm going to have an I quickly hop outside the radical, and that will make this positive. Okay, now the reason why I can do that, you guys, I'll kind of explain on the side. Okay, I'm just going to demonstrate something for you. All right, the square root of -216. What that equals is the square root of -1 times +216. Okay, and with radicals, you can break them apart if they have a multiplication. So this is the same thing as the square root of -1 times the square root of 216. Okay, which the square root of -1 we know to be I. So this is an I. So this is like I times 216. Okay, so that's what's going on in the background. But the shortcut is if you see a negative to turn that bad boy positive, and I will hop out. And bam, we have a +216 now. Okay, so I'm going to do this the same as I did over here. I just have a much larger number. So let's break it on down. I'm going to do my factor tree. Alright, I'm going to think of two things that go into 216, which a lot of things go into 216. Okay, but you can pick whatever you want and you will still end up with the right answer. I promise you guys. So what I'm going to do is 3 times 72. Those two things go into 216. I can't break down the 3 because the only thing that goes into 3 is 1 in itself. But I'm going to break down the 72. Two things that go into 72 are 9 and 8. Alright, which I can keep going. Holy hot dog, right? Alright, the 8 will break down into 2 and 4. Okay, I can't break down the 2 because the only thing that goes into 2 is 1 and 2. But I can break down the 4. The 4 will break down into 2 and 2. And finally, my 9 can keep breaking down into 3 and 3. Okay, so now what I'm going to focus on, you guys, is only the numbers at the ends of the branches. So anything that broke down, I'm going to cross out so I don't even think about it. So like the 216 broke down, so I'm going to cross it out. The 72 broke down into 8 and 9, so I don't care about it. Okay, the 8 broke down into 2 and 4, so I don't care about the 8. The 4 broke down into 2 and 2, so I don't care about that. And the 9 broke down into 3 and 3, so I don't care about that. So the only things I care about are these numbers at the ends of the branches. And I'm looking for cute couples that will go out on their hot math date. Okay, so I'm looking for pairs of numbers, you guys. And again, it does not matter where they are in the tree when you pair them up. Okay, so let's see. I'm going to start with these 3s. Do you see a pair of 3s? Holy hot dog, I see several options. I could pair up these 2 3s. I could pair up these 2 3s. I could pair up these 2 3s. Okay, so there's several options. Now, I'm just going to circle these two since they're close together and it makes my life easier, but you don't have to. Okay, so these are a cute couple. Okay, and since I circled one, that will leave the square root and go out on their hot math date. So my 3's are going to hop out. All right, do we spot any other pairs? Holy hot dog, I have a bunch of 2's. Okay, I could pair those 2 2's, I could pair those 2 2's, or I could pair those 2 2's. Again, since these are close together, I'm just going to circle these. So now I have another pair. So I have another Q couple that gets to go on their hot math date, so they will also hop outside of my radical. And remember, you guys, for each pair, only one will hop outside. And remember, you guys, if you have more than one number, okay, you will multiply them. Okay? Now, I do not have any pairs left. All I'm left was a 3 and a 2. Now, before I forget, this I is still hanging out outside. So I'm going to put my I in there so I don't forget about it. Okay, so all my single lonely numbers, my 3 and my 2, they don't have a cute couple to go on a hot math date with. So they will stay in their square root. So my 3 and my 2 are both going to go in here. And since I have more than one, I will multiply them, the 3 and the 2. Okay, and the last step, you guys, is to multiply everything. Let's go. 3 times 2 is 6, and 6 times I is 6i. When you guys deal with I, kind of treat it like a variable, but it is not a variable. It's secretly -1, the square root of -1. Okay, so we treat it like a variable when we work with it, but it's not a variable, so be careful. So this will be 6i times the square root of 3 times 2, which is 6. So this will be my final answer, you guys. Holy hot dog, right?